Task 2 from page 310, Discovering Statistics Using R, is asking that we conduct a regression analysis, that we decide whether age, ears, and beauty are predictive of salary of supermodels. And the second part of the task is to decide if this is a valid regression model. As you can see, I've already uploaded the data set, supermodel. I've activated R Commander, and I've activated the supermodel dataset in R Commander. So regression analysis is very simple statistical analysis in terms of the steps that we need to perform to conduct the analyses. Simply click on Statistics, Fit Models, Linear Regression, and the field prefers to refer to an outcome variable or a dependent variable as an outcome variable. R prefers to refer to it as a response variable. Same thing. We are interested in predicting salary. So the response variable is salary by the variables age, beauty, and ears. Let's go ahead and name this model something else. Let's call this supermodel 1. And all we need to do now is click on OK. As we click on OK, let's click on Yes. Actually, I'd already conducted the analysis once, so supermodel 1 already existed. We can see the output here. The first thing that we see is that there's a linear model with a formula that says salary is being predicted by age, beauty, and ears from the dataset supermodel. R gives us a descriptive or a summary of the residuals from -24 all the way to 68. Residuals are important in regression analyses, and we're going to get to see that later on as we explore the goodness of fit or whether this is a valid model or not. Instead of looking at the coefficients now, let's go ahead and look at the F statistics, or sometimes this is called an ANOVA summary. The F statistics or F ratio is 17.7, which already gives me the idea that it's a relatively large ratio, and that is of what we know and what we don't know, or what we can explain and what we can't explain. And when I look at the p-value, we find that it is significant, less than 0.05. Matter of fact, it's actually less than 0.001, which is not necessarily any more significant, but significant. So we have a significant model. Next thing that I would look at is R squared. R squared tells us what percentage of the variance is accounted by these three variables, age, beauty, and ears. And in this case, we have 18% of the variance is accounted for by these explanatory variables. Adjusted R square is actually specifically what it says that it is. It's an adjustment on the R square that changes usually up and up to R squared if we add more explanatory variables into the model, and these explanatory variables actually improve the model. So if we were to add 3 extra variables into this model, geographic location, so if you live in New York or California or in Texas, do you make the same salary? If that improved the model by explaining more of the variance, then the adjusted R square would increase and would move closer to R squared. If there was no movement in the adjusted R square, then we would say that this variable actually had little improvement in the model. If we actually see that our adjusted R square starts deviating away from R squared, then we would consider that the variables that we're inserting into the model are actually weakening the model or making the model less efficient. So the ideal model is the model that has an adjusted R squared that is very close to the R squared that we have reported. In this case at 0.18 and at 0.17, this is a pretty good model. We could make that decision at this point. Next thing we're going to look at is the coefficients. Coefficients help us interpret the specific variables that we've entered, or explanatory variables that we had entered into the model. If we look at ears is telling us that there is a negative relationship with salary. So the more we increase in ears, the lower the salary becomes. And this could be true to an extent. But we're going to see this is actually true when we analyze the goodness of fit, or whether this is a valid model or not. Beauty, in this case, is actually negatively related to salary as well. But because we see that beauty does not have an asterisk, this is not a significant predictor. Therefore, the relationship between beauty and salary is not significant. So we should not necessarily spend time examining this, other than if we write a results section simply saying beauty was not found to be a significant predictor of salary. Age, as we see here, has a positive relationship as we look at the estimate at the beta. At 6.23, a positive 6.23, we could interpret this to mean that as age increases, also does salary. If the unit of age is 1 year, we could say that an increase of 1 year in age of a supermodel will result in a 6.23 increase in salary for that supermodel. We can also see by the asterisk that this is a significant predictor. There is actually not those, but these, that age is a significant predictor of salary. So that would be the actual regression analyses and a basic interpretation of the output that is provided by R. The next question is whether this is a valid model. I will make an educated guess now. This may not be a valid model. As we're looking at years and age, it appears that years of experience and age may be measuring a very similar construct. So if you are 40 years old and you've been in the modeling industry for 20 years, that means that you started at the age of 20. Wouldn't those two measures be very similar? Well, we need to look at that. Next video is going to do this for us.